And here we go, ladies and gentlemen. Lesson 4-10, two-step equations. Sorry, I should have gotten rid of the multiply and divide because two-step equations will have a number of different operations. We're about to find that out. Please go ahead if you need to pause and take a look at assignment number 35. Come on back when you're ready. And so as we see, we've been in one-step equations. Maybe those one-step equations have add or subtract or multiply or divide. Moving up into two-step, which eventually will build us into multi-step equations. But for now, our goal is to get rid of coefficients, get rid of any constant terms, find out what that missing variable is equal to. Go ahead and pause for a second. I did change the problems. We're going to only do 11 to 41, odds only, odds only. Go ahead and title your paper. Come on back when you're ready for some examples. So here's some basic instructions, all right? When it comes to two-step equations, almost always, I will say almost always, the very first step is to simplify using the inverse of addition or subtraction. If you got an extra couple bucks, or if Mr. Count was mean and took some dollars away, put those dollars back in or take those dollars away. Get rid of the add or subtract first. And then, almost always, we're going to simplify and solve using the multiplication and division operations. Now, let me show you what I mean, but you know me. I'm going to start off with, excuse me, some basic drawing. All right, first of all, when you look at this term, do you see one envelope of money, lots of envelopes of money, or a part of an envelope of money? Well, in this case, we do have 4 different envelopes of money. Oh, excuse me, it's actually the opposite of an envelope of money. Oh, and then we do have that additional $4. Tell you what, instead of plus ones, I'm just going to write plus signs. On the other side, we got $20 bills over here. So I'm going to draw 20 pluses. Now, because we're getting into positive and negative integers, perhaps you'll see why in a moment we're going to use plus signs. All right, we know what our goal is. Our goal is to find out what m is. So a little disappearing ink here. We got to get rid of the negative 4. We got to get rid of the positive 4. But the first thing I ask is, which one of those numbers has nothing to do with the envelopes of money? And that would be this plus 4 down here. So what I'm going to do is I'm going to rewrite the equation. I'm going to leave a little space. Now, some of you will write minus 4. Some of you will write a negative 4. I don't care how you write it. We're going to go ahead and subtract. Or once again, you can write add the opposite and see why this works. Now, naturally, positive 4 and negative 4 cancel out, because all these make 0 pairs. Some of you circle them, some of you cross them off. And please notice that does get us one step closer to getting m isolated and alone. I should have pointed out that over here on the other side, we do have positive 4 and negative 4 crossing off, leaving us with 16. Okay, but we don't want the opposite of 4 m's equal. We just want to know what m equals. So you can imagine at this point, we're going to split up into 4 groups. If I were to rewrite negative 4 m's, the opposite of 4 m's equals 16, we're going to go ahead and we're going to split it up. And wait a second, I'm going to catch myself immediately. Because if you look what happens here, 4 divided by 4, sure, that cancels, but look what that leaves us with, the opposite of m. Who wants to know what the opposite of m is? We want to know what m is. Therefore, instead of just dividing by a 4, we're going to divide by the opposite of 4. In this case, 4 divided by 4 leaves us with a single m. The opposite of a negative is a positive. Now notice I'm going to change all these signs over here to opposites. Opposite of negative. But that also means that each one of these signs, the opposite of all those positives, become negative. And therefore, as you can probably already imagine, Our solution is -4. Now, if you don't believe it, we can come back here. Sorry, I'm running out of space. We're going to write the equation again. But we think we know what that answer is. Let's find out. 4 -4 is the opposite of going down repeatedly, is to go up repeatedly. Is 16 plus 4 equal to 20? It sure is. Sorry, I ran out of space. So once again, I'm just showing you visually with the drawing, as well as numbers and symbols on the left, how we can use inverse operations to solve equations, even two-step equations. Let's move on to another example. In this case, I'm not going to draw it out, but you can always pause, go back and rewatch that first example. All right, what are we going to get rid of here, the -6 or the -5? Well, that -5 has nothing to do with the envelopes of money. So let's get rid of the -5 by adding 5. The opposite of a negative is a positive. Those will cancel out. That leaves us with -6r's equaling -42. Go down 47, go up 5, you're still well underwater. Now, in this case, we don't want the opposite of 6. Imagine multiple envelopes of money. We're going to split it up, but not just split it up into 6 parts. We need the 6 and the opposite symbol to cancel out. So we're going to divide both sides by -6. And naturally, the opposite of negative is going to be +7. Does that work? Let's go ahead and substitute in 7. I put a little question mark here. In this case, -6 times 7, the opposite of going up repeatedly is to go down repeatedly. I'm going to go ahead and change subtraction to adding the opposite. And we see a -47 is in fact equal to a -47. True statement. All right, let's move on to something different. Whoa, wait a second. All right, pause for a sec. What do we have here? When you look at this term, do you have one envelope of money, lots of envelopes of money, or a part? We have a part. In fact, we have a fourth. So if you'll forgive the ugly drawing, let's go ahead and take note that we have a portion of an envelope of money. And then we have -7. 1, 2, 3, 4, 5, 6, and 7. On the other side, very interesting. We have a positive dollar. I'm just going to write a positive sign. You're welcome to draw ones if you ever want to draw ones. Okay, goal, R equals. But right now we have a part of an R, and then we have that pesky -7. So what are we going to do first? Well, we're going to get rid of that -7. In order to do so, you might imagine, if we want 7 minus symbols to cancel out, we're going to do 7 plus symbols, and naturally, we're going to add 7 or a +7 to both sides. Now, in this case, -7, +7, cancel out. And what does that leave us with? Well, that's pretty good. We're one step closer to getting R isolated by itself. But remember, we don't want a part of an R, we want a whole R. So if part of this R is, it appears, +8, let's go ahead and figure out what the whole R would be. So if that part is 8, then that part is 8, and that part is 8. Now, what does that mean symbolically? We need 4 parts to make the whole. Oh, no, 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 no. See, that would give us the opposite of R. That's no good. So instead of just multiplying by 4, you guessed it, we're going to multiply by the opposite of 4. Every one of those 8s will change because we had to take the opposite of all those pluses. Now, in this case, 4/4 makes one whole. No, you do not have to write the 1. And the opposite of a negative is a positive. Meanwhile, what does that leave us with on the other side? 4/8 is 32, and then the opposite of all those positives are negative. Now let's go ahead and check to see if this works. By rewriting the equation, and substituting in what we believe to be the answer. In this case, the opposite of all those negatives turns to positive 8. And what is 8 plus negative 7? It is equal to 1. So you continually see that we're trying to get rid of, in blue, we're trying to get rid of those constant terms first by adding or subtracting. And I will say again, almost always we do that. Then we proceed to get rid of the coefficient, whether that be through multiply or divide. Let's do another example. Looking here, once again, we see that we have part of an envelope of money, but it doesn't matter because we're going to get rid of that pesky $4. Before that $4 was added, we can take away that $4 and find a part of it is negative 5. But be careful here. We're not dividing both sides by 5. It's already divided by 5. We have a part where we want the entire thing. So if part of that were negative 5, let's multiply. Do we have to multiply by negative? No. Because 5/5 gives us 1 whole r, and that is what we wanted, r equals. Meanwhile, 5 negative 5s makes negative 25. Don't believe it? Check it. Negative 5 plus 4, is that equal to negative 1? Yes, it is. So I hope you're starting to put, today is really nothing new. We've already had two-step equation skills. We've already had positive and negative integer skills. It is challenging, though, because we're combining those all with the ultimate goal of solving for that missing piece. Let me give you one more real quick. No, I think that's good. Actually, that's one we already did. So bringing it back to our homework sheet. Remember page 113, 11 to 41. I know this is a long video. That's why I wanted to trim down some of the homework. Take your time, do well. I will be available off and on throughout all day. I might actually start parent conferences and phone calls early. But I'm here for you. You guys are my first priority. So message me, email me if you need anything. Thanks so much, and let's grow.